Okay, as I anticipated, I ran out of time from the previous video, so this is part 2 of the same problem. So in the last video I got caught off, but what I was trying to say, let me get this going, is that in essence we're just making lots of triangles, and what we're solving for is this big triangle in red right here. Oops. Try to make this a little straighter, there we go. Just like that. And that's what we're solving for, which happens and we're finding this angle. Now, this just happened to work out such that this is really the 58 right here. Sorry, that's a little confusing, right? This is a different angle than this one. So that's what I want to do next, is basically find my x total, if you will, my y total. And once I do that, I'm going to find this big hypotenuse, which is going to be our answer, our resultant, r. That's what this is right here, r. Okay? So, you could do it any way you could do with the, one method is to do the x and y method, or you can just do exactly what you might do when you add up the x's, is just add them up, right? So, my first x is right here, so 1306.24, that's the first one, plus the second one, 348.18, plus the third one. We want the x one, so it's the 320. So be careful. I'll get a number for that. I'm just going to set it up. Now we're going to do the y total. Same thing. Let's see if I can get it all on one screen. Oh, I can. Cool. So that will be 2131.60 meters. So I got that here. The y is the y is here, so plus 139.26 meters plus the y. Here we go. The y 814.12 meters. There we go. So now I'm gonna spend a second and calculate these out. So here we go. Oops, 1306.24 plus 348 plus 320.69. So I get a nice large number here, 1975.11 meters. So now I'm doing the next part, so 2131.6 plus 139.26 plus 814.12. Although it sounds silly that I'm saying it out loud, it actually helps me accurately put the numbers in my calculator without making an error. So there's a value to doing that. Well, I guess that's okay. So I boxed these just to kind of make them easier to see as I do my next calculation. So that's what we did. X total, y total. Now we got to figure out the hypotenuse of the red triangle. So let's just draw a new triangle because it's just easier. So my x is this 1975.11. I did not draw this to scale at all, so keep that in mind. This should actually be much larger, so this would be a greater angle. So we need r in the angle. R is going to be using the Pythagorean theorem, so we're going to do x total So you could actually put this on your equation sheet if you like, r is equal to this, because that would be really helpful. But what we're doing is just solving the Pythagorean theorem. So 1975.11 squared plus this. Oops. R equals those things. Great. This looks like a good number. Am I good? I know the answer, so this is the answer. So that's r. So right now that's the hypotenuse that we just calculated. And we're not done because we found the magnitude of our vector, or in other words, we found out how large it is. Now we need to know the direction of our vector. So now that I have all the pieces of the triangle, I can use any trig. I happen just to like tangent, because tangent's going to be my y over x. And these are the totals, by the way. So let's do that. If I do the inverse tangent to find the angle of the y total, I'm just doing the extra step here. I'm doing it really explicitly. Equals the angle. So in order to get the angle of something, you have to take the inverse of it, just like that. So here we go. Tan inverse of the y. So you have to be careful. It has to be y over x. And then the x. So I'm going to do that. Let's do it. 3,084.98 divided by 1975.11. Inverse tan of the angle. And then what we get here is 57.37 degrees, just like that. So it happens to be actually very similar to that one, just by coincidence. So the official final answer you would write on an exam would be R equals 3,600, comma, 3.08 meters at 57.37 degrees above positive x axis. Now you have to say this line right here because this angle can be measured going below the negative x. You know, this can go below the x-axis, above. It can be from the north, from the south. So you have to be very specific to where you're measuring it. Another way to say this is in the context of the problem, which is north of east. This is also accepted as an answer. But anyway, just being very particular about where you're measuring that angle. So this would be half the credit, which is the magnitude, and then the direction. You need both because this is a vector. Okay, so that concludes this solving this problem.